recurrence relations is all about sequences of numbers. So you might have sequences that go on and on and on. There's one sequence there. Then you might have another sequence that starts off bigger numbers, it doesn't matter, and it goes on and on and on. Now, what we want to know for recurrence relations is we want to know how do we get the next term if we know the first one. So it might be like if I give you a term 2 and I say, right, this sequence is to multiply by 2 and add on 1. Then to get the next term, I do 2 times 2 is 4 plus 1 is 5. So recurrence relations are telling you that. What do you do to the term that you know to get the next one? So that stands for the next term. So I'm going to make up a recurrence relation and I'm going to say 2un plus 10. So for me to get the next term, I take the term I know, I multiply it by 2 and I add on 10, just the same way as I did for that one. Now, when you're doing a recurrence relations, if you want to find one of the terms, you've got to be told a starting point. So you're either told u1 is equal to something, or you might be told u0 is equal to something. So you're given one of them. So here we've got u0 and that's equal to 1. That's our starting point. So to get the next term after u0, it's u1, and u1 is equal to 2 times u0 plus 10. And then you can work it out, but you must write down this formula first. So u1 then is 2 times 1, add on 10, and that gives us 12. If I wanted to work out u2, so looking at the recurrence relation, the next one is equal to 2 times the one that came before, so it's 2 times u1 plus 10. So to get the value for u2, u2 is equal to 2 times u1, so it's 2 times 12, add on 10, and that will turn out to be 34. And you can keep going. But if I ask you to work out, say, u20, you'd have to go through all of them. So to work out any term, you've got to start and you've got to go through all of them, which is a wee bit of a disadvantage, but you would never be asked to go and work out one that's a wee far away. So that's basically what a recurrence relation is. Now, sometimes you've got sequences and they might get bigger and bigger and bigger, but sometimes you get sequences that go on and they stabilise at a certain number. So you could have something 3, 2, 3, 3, 4, 4.5, 4.5, and then if I go away to maybe 1,000 terms, it might end up at 5. The next term would be 5, the next term would be 5. We see that this sequence tends to a limit, and that limit is just the number that it keeps repeating. It's the number it keeps going to. Now, there's terminology. That could be the first term, we call it u1. That could be the second term, we call that u2. That could be the third term, we call that u3. Now, all of these ones, that's the limit. But that could be, say, un. That means any number. That could be the next one after it, would be un plus 1. And if I really want to go one further, I could say that's un plus 2. But when we get to this limit, then we know that all the terms, it doesn't matter what they are, they're all exactly the same as a limit. Now that's basically all you need to know about recurrence relations. There are 3 main types of questions that you're asked for recurrence relations, and I'm going to go through all of those ones. And if you look at the videos, you'll learn them, you go back and you do the questions yourself, then you'll be okay with this topic. So first one we've got here. So first one I've got here is a typical question. It's in paper 1, so you don't have a calculator. So it says a sequence is defined by un plus 1 is equal to 3 lots of un plus 4. So what that means is to get the next term, you multiply the term you know by 3 and you add on 4. So it's like your machine chain rules. So you're timesing by 3 and you're adding on 4. That's the more baby method of writing it down. When you were in first and second year, this is the more mathematical way of writing it down. Now, you need to get a starting point. You need to know where to start to put a number into that. So they've given us u1 and they want me to work out u3. So u1, we're told, is equal to 2. So what do I do to get u2? So u2, the next term, has got to be 3 times the term that comes before, add on 4. So it's 3 times u1 plus 4. That's the formula, and it's important you write that formula down. Now you can work it out. So it's 3 times 2, add on 4, 3 2s are 6, and 4 makes 10. They want me to do U3, so I do U3. So how do I get U3? It's 3 times the term that came before, add on 4. So it's 3 times U2 plus 4. Now I can put numbers in. So it's 3 times 10 plus 4, which gives me an answer of 34. So that's a typical question. You might get U5, you might get U6. You have to go through them all. And sometimes you start off with U0, but that's okay. Because if you start with U0, then the first term would be U1, and it would be equal to 3 times U0 plus 4. And that's how you would start that one. Okay, but you were given U1. So another type of question like that, we will do. Okay, so next one is this one. A sequence is generated by the recurrence relation un plus 1 is equal to a quarter of un plus 7. So basically, what this wee machine chain is doing is it's finding a quarter. That's the same as dividing it by 4. And then it's adding on 7. And you're getting a starting point. So your starting point is u0 is equal to -2. Now this one, it says find the limit as n approaches infinity. So that means that we've done thousands and thousands and thousands of terms, and we've kept doing that. But what's happening here is we are getting a limit. We're getting to the stage where all the terms are going to be exactly the same value. Now there is a way that we know if a limit exists, and the way to tell is if this number here, the number in front of un, if that lies between -1 and 1, then a sequence will have a limit. Now this has got a limit because a quarter is 0.25, so it lies between -1 and 1. So I know it's got a limit, but they're asking me anyhow, so we know. Now, when we get to a limit, we know that the next term is equal to the term that came before, and it's equal to that limit. That's what that means, and just words. So what we do is we substitute L in for each term that's there. So we'll have L is equal to 1/4 of L plus 7. Now that's like an equation. Here, that really stands for 1L. I want to get all the L's onto one side, so I'm going to take a quarter of an L away from both sides. And when I take a quarter away from 1, I'm left with 3/4. So 3/4 of L is equal to 7. And it's an easy calculation after that. That means 3 times L divided by 4. So to undo that, we do 7 times 4 divided by 3. So we're undoing that one. So 7 fours are 28, and 28 divided by 3, that's a fraction in its simplest form. If you want, you can change it to mixed number. So 3 into 28 goes 9 times. 3 nines are 27, there's 1 left over, so it's 9 1/3. Okay, that answer's adequate because it's a fraction in its simplest form. If you don't have it in its simplest form, then it's not okay. Okay, next one. We're going to have a combination of the things that I've done so far. So a sequence is defined by the recurrence relation un plus 1 is 1/3 of un plus 10, and they're starting me with the third term. They're telling me the third one. They want me to find the fourth one, so that's okay. The fourth one leads on from the third one. So what I've got then is I want to work out u4. So u4 is equal to, the next term is 1/3 of the one that comes before. So the term that comes before u4 is u3, and then I've got to add on 10. So now we can stick some numbers in. So it's going to be 1/3 of 6. Then I want to add on 10. 1/3 of 6 is 6 divided by 3 is 2. 2 plus 10 makes 12. So u4 is equal to 12. So that's the fourth term in this sequence. We don't know the first term, we don't know the second term, but we know the third and fourth, but it doesn't matter. So next thing, it's only for 1 mark, that question. This one's only for 1 mark as well. It says explain why this sequence approaches a limit. You learn this, and it's 1 mark that you've definitely got. So we'll look at the number in front of un. This number here is 1/3. And we've got to decide a limit exists if that 1/3 lies between -1 and 1. So I'm drawing it. 1/3 is in between -1 and 1, and the arrows always go that way. So explain why the sequence approaches a limit as n approaches 0. It does that because 1/3 lies between -1 and 1, and that's you explained it. So the next thing, they're going to ask me to work out this limit, calculate the limit. So we'll go up here, and I know that when a limit exists, un plus 1, the next term is equal to the term that came before, and they're all the same as this limit. All the terms are exactly the same. So I can write that down, and then I can go and I can substitute L in for each of these terms. So L is equal to 1/3 of L plus 10, a simple equation, and I solve it. So I want to get all the L's on one side, and again, we have to remember that L is 1L. So I'm taking 1/3 of L off both sides. So 1 take away 1/3 leaves me with 2/3, and it would be 10 left on the right-hand side. I want to simply do that recalculation to get L. So that means 2 times L divided by 3. We do the opposite, so it's 10 times 3 divided by 2. So that works out to be 15. So the limit of this sequence is 15. Another type of question you get is this one, where you're given your recurrence relation. So they tell you a sequence is generated by the recurrence relation, same wording all the time. So the next term is equal to m, which is something, we don't know what it is, times the term that came before, and we've got to add on something. So we're really working backwards with this one. There is no catches in any of these questions. They're all exactly the same. We do exactly the same thing. They come up all the time. You learn how to do them, and you're guaranteed the marks. So what does this mean? It says the first 3 terms of the sequence are 6, 9 and 11. Well, U1 has got to be the first one, so that's 6. U2 is the second term, that's got to be 9. And U3 has got to be equal to 11. So that's the information we're given. We're going to substitute these 3 things in to get 2 simultaneous equations, and we're going to solve them. Now what you do is, if you've got 3 pieces of information, start in the middle. So we're going to start off and we're going to say, right, U2, what is U2 equal to? If that's U2, it's going to be m times U1, add on C. Then we look at the last term, which is U3. So U3 is equal to m times the term that came before it. So it's m times U2, add on C. So they're always linked to one another. That's the next term, that's the one that came before. So if that's 2, that becomes 3. If that's 1, it becomes 2. So that's why you start your first equation at the middle one, because you're linking that one to what did you do to the one that came before. So you've got to start here for your first equation. Now, once you've got that cracked, all you do is you substitute in those numbers and you'll get 2 basic simultaneous equations. They're not hard simultaneous equations, they should always be straightforward. So U2 is 9, that's equal to m times U1, and U1 is 6, and we've got a plus C. Now I don't like how I've written that, so I'm going to turn it all the way around, and I'm going to say 6m plus C is equal to 9, and that's in a better format that we are used to. Now same for this one, U3 is m times U2 plus C, so U3 is 11, and that's equal to m times U2, which is m times 9, add on C, we don't know what C is. We'll tidy that wee equation up, and that would be 9m plus C is equal to 11. Now these equations will always, they'll never be different. You'll always have plus whatever letter they use in there and plus whatever letter they use in there. So back to National 5, we did same sign subtract. So we do the same here. So I'm going to write those 2 equations down. Now to make sure I'm not dealing with negative numbers, I'm going to take the biggest one first. So we'll take the one with the highest number first, which is 9m plus C is equal to 11. So we're eliminating C, and we've got 6m plus C is equal to 9. So same sign, subtract, a big bracket right the way around that, and we're subtracting 1 bit at a time. So 9m take away 6m leaves me 3m's. C take away C is 0, that was the whole point of that. Then we've got an equal sign, and then I've got 11 take away 9, and 11 take away 9 is 2. So that's me, I can work out what m is. I don't want 3m, I'm going to divide by 3, so m is equal to 2/3. Now the next thing I want to do is I want to work out what C is. So we're going to sub m equal to 2/3 into, and we'll pick one of those equations. Usually you pick the one in the smallest numbers. So we'll substitute it into 6m plus C is equal to 9. So when I sub that in, I'm going to get 6 times 2/3, add on C is equal to 9. Now you will get fractions in these, that's the whole nature of them, but they shouldn't be difficult fractions, and you've passed your National 5, so you know how to deal with harder fractions than that. So first of all, we're going to start off and we're going to do 6 times 2 is 12, 12 divided by 3 is 4, so 4 plus C is equal to 9. I'm going to get back to that one. 3 into 3 goes once, 3 into 6 goes twice, so that could be 2 times 2 is 4. So it doesn't matter which way you do it, okay, you'll still get the same answer, so whatever way you find easier. Now I want C, so I don't want that 4 to be there, so I'm going to take 4 away from both sides. 9 take away 4 leaves me with 5. So that means I've worked out a sequence, so I know that UN plus 1 is equal to M, which is 2/3 UN, and with a plus 5 stuck at the end. That's the recurrence relation. So I'm going to explain what that one means. To get the next term, you do 2/3 of the one that came before, and you add on 5. That's how you get that term. So I've chopped this question so we can see it again to do the next part. So it says we've got to hence, to use what we've got before to calculate the fourth term of the sequence. So to get the next term, I do 2/3 of the term that came before, and I add on 5. Now I want the fourth term, so I want U4. The term that came before U4 is U3, so it's 2/3 of U3, add on 5. We know what U3 is. There's the third term, 1, 2, 3. There it's written down there is 11. So U4 is equal to 2/3 times 11, add on 5. So we tidied that up a wee bit. So 2/3 of 11 is 2 11s are 22 over 3. And we've got to add on 5. I'll change this into a mixed number. So 22 over 3. 3 into 22 goes 7 times and 1/3. And then we've got to add on 5. So 7 and 5 is 12, so that's 12 and 1/3. Now you could work that out as a top-heavy fraction, whatever. Okay, but not a decimal because we want to keep them accurate. Okay, another past paper question that we've got here, and it's question 1. I think this one is in the calculator paper, and it's worth 7 marks. You'll learn how to do these. They're all very similar. So we start off, a sequence is defined by UN plus 1 is equal to half UN with U0 equal to -16. So this sequence doesn't have something added on at the end, it's just got this wee number in here. But they're telling me the starting point is U0 is equal to -16. So determine the values of U1 and U2. So I'm going to try and write it in here so that we can see the question all the way through. So U1 is going to be equal to, so the next term is equal to -1/2 times the term that came before, so it's -1/2 times U0. There's nothing added on, so I can go straight in and do -1/2 times U0 was -16. 1/2 of 16 is 8, 2 negatives make a positive, so the first term in that sequence is 8. I want to do U2, so U2, that's the next term, so it's -1/2 times the term that came before, so that must be U1. So it's going to be -1/2 times U1, we've just worked it out, it's 8. So -1/2 times 8, 1/2 of 8 is 4, 1 negative leaves it as negative. Now we move on to another one, 3 marks, there's more work involved in this second bit. It says a second sequence is given by 4, 5, 7, 11, and it goes on and on and on and on. So it says it is generated by the recurrence relation Vn plus 1 is equal to Pvn plus Q with V1 equal to 4. So the first term in this sequence is 4. We can see it's 4, there it's there. They've changed from U to V because we're talking about 2 different sequences, but still exactly the same work that we're doing. So first thing we've got to do is we want to find the values of P and Q. That's exactly the same as the one that I did a minute ago. We're finding these values here by substituting in numbers and solving a simultaneous equation. So for this one, I'm going to put in a few wee values here. So that must be V1, the first term, that must be V2, that must be V3, and that must be V4. I've got loads of terms here, so I don't really need them all. So it says a sequence is generated by the recurrence relation. I'm going to go to the second one, so that means that V2 is equal to P times the one that came before is V1 add on Q. I know that V3 is equal to P times the one that came before it is V2 add on Q. Now I could also do V4 is equal to P times U3 plus Q, but I only need 2 because it's simultaneous equations. So now that I've got those 2 equations, I'm going to substitute in some numbers. So we'll substitute the numbers into that. So V2, the second term, is 5. So 5 is equal to P times V1. P1 was 4. And we've got to add on Q. That's my first simultaneous equation. The next one, V3, so the third term is 7. So 7 is equal to P times V2. and the second term was 5, so it's p times 5 plus q. Now I'm going to tidy those equations up. So that first one is 4p plus q is 5. So I've got 4p plus q is equal to 5. And that one there, it's got bigger numbers, so I'm going to write that one at the top. That's 5p plus q is 7. So that one is 5p plus q is equal to 7. That's my simultaneous equations. Same sign, subtract. It will always be same sign, subtract. They will always be the same, which makes it dead easy because you'll learn how to do them and you're not going to get any tricks in this. So we've got 5p take away 4p is 1p. I've got q take away q is nothing. That was the whole point of it. Then I've got the equal sign, and then I've got 7 take away 5 is 2. So that means that p is equal to 2. So we're going to sub p equal to 2 into one of those equations. I'm going to pick the one of the lowest numbers. So 4p plus q is equal to 5. So that's going to be 4 times 2 add on q is equal to 5. That gives me 4 2s are 8. So 8 plus q is equal to 5. Take 8 away from both sides, so q is equal to -3. So we've now worked out p and q that you can see here. So that recurrence relation becomes Vn plus 1 is equal to p, which is 2 Vn, add on q, but it's a -3, so we just say -3, we don't need the plus. So that's the second sequence. Okay, that's how it's worked out p and q. Exactly the same working as we did when it was m and c in the previous question. Now there's another part to this question, so we'll have a wee look at the third part. Third part of this question is either the sequence in A or the sequence in B has a limit, and we've got to calculate that limit. So the sequence in A, the two sequences we're talking about was un plus 1 is equal to -1/2 un, and the other sequence we were dealing with was Vn, so Vn was equal to, okay, the one we just worked out in part B was Vn plus 1 is 2Vn minus 3. So it says one of them has got a limit, and then we've got to calculate that limit. So we'll look at the two sequences. To determine whether there's a limit or not, we're looking at the number in front of un or Vn. So that number's got to lie between -1 and 1. So 2's out with that, so there's no sequence for that one, or no limit I should say for that one. Okay, so there's no limit. And the other one has got a limit because -1/2 lies between -1 and 1. So I can write it like that, put in the arrows going that way, so a limit exists. Now, what they want me to do is they want me to work out the limit of that one. So I'll write this down here. So if we're working out the limit, then un plus 1 becomes un and it becomes L. So L is equal to -1/2 L. There's nothing else there, but don't worry about it. We solve it the way we always do. That's 1L. I don't want L's to be on this side, so it's -1/2 L. So we're going to add 1/2 L on to the other side. And when I add 1 plus 1/2, that's 1.5, which is 3/2L. Now, on that side, there's now 0, there's nothing. So if 3/2L is equal to 0, then L is equal to 0 multiplied by 2 divided by 3, it's still equal to 0. So the limit of that sequence there is equal to 0. Okay, the next type of question you get is more wordy, okay, but it's a bit similar to what we've done before. It says, in a forest, the population of a species of mouse is falling by 2.7% each year. To increase the population, scientists plan to release 30 mice into the forest at the end of March each year. UN is the estimated population of mice at the start of April. N years after the population was first estimated, it is known that UN and UN plus 1 satisfy the recurrence relation that state the values of A and B. This question is very similar to your percentage questions in that 5. So if the percentage is falling by 2.7%, it starts at 100%, it falls by 2.7%. We want to know what percentage is going to be there. So 100 take away 2.7 leaves me with 97.3%. Now, you can't put 97.3% into a calculation. You've got to change it to a decimal, so divide it by 100, so 0.973. So now we go and we fill that in. So we've got UN plus 1 is equal to 0.973 times UN. But what happened? They added an extra 30 mice into the wild, so it's plus 30. And that's our recurrence relation. Now, that's us. We've got A and B. We've got the number in front of that, and we've got the number there. Okay, so that was a wee bit different from the one where you're given 3 terms and you have to work out A and B. Next thing you've got to do, it says explain why the estimated population of mice will stabilise in the long term. That's key for does it go to a limit. So the number of mice should settle at a certain value and all the numbers in sequence should turn out to be the same. So if that's the case, then UN plus 1 should be equal to UN and it should be equal to L. But we need to state if the limit exists. Look at the number in front of UN. Does that number lie between -1 and 1? It does. So therefore, a limit exists. We do the same thing. We write 0.973 between -1 and 1. And just remember the arrows go that way. So a limit exists because of that. It's only 1 mark and it's easy to learn. So the next thing you've got to do is you've now got to calculate that limit. So we know that every term turns out to be the same. So we go back up to our recurrence relation. So L is equal to 0.973L plus 30. We want to gather all the L terms to one side. So I know L is 1L, so I'll stick a wee 1 in there. I want to take 0.973 away from both sides. And when I take that away from both sides, I get 1 take away 0.973 becomes 0.027. And that's times L, and that's equal to 30. So now I want to work out what L is. So L is equal to 30 divided by 0.27. There's a wee extra 0 in there. It's a calculator paper, so therefore I can work that out using my calculator. It comes out to be that. Now always go back and read the question, same as you did in that 5. It says we want the population to the nearest 100. There's only 2 marks for this question. One of them will be for rounding it to the nearest 100, and one of them will be for that calculation. So that mark's pretty precious. You don't want to lose half your marks because you haven't rounded. So to the nearest 100, that's going to be 1,100 mice that will settle at. Okay, so that's a word equation, a couple of bits in it, but you learn how. Okay, another typical recurrence relation question, lots of words in it, so we read it carefully. So it says, a man decides to plant a number of fast-growing trees as a boundary between his property and the property of his next-door neighbour. He has been warned, however, by the local garden centre that during any year, the trees are expected to increase in height by 0.5 metres. So that means they grow every year by 0.5 metres. In response to this warning, he decides to trim off 20% of the trees at the start of any year. If he adopts a 20% pruning policy, in other words, if he does cut off 20% of the height, what height will they be expected to grow to in the long run? Long run code for limit. But we need to get a recurrence relation here. So he starts off the trees at 100% height and he's going to cut 20% off. So that means the height that's left there is 80%. We can't use 80%, so we change it to a decimal, so it's 0.8 or 0.80, it doesn't matter. So that means we've got UN plus 1 is going to be equal to 0.8 UN, so 80% of what they were before. But we know that they're growing, so there's an extra 0.5 metres being added on every year. So they grow by 0.5 metres. So that's a recurrence relation. We now want to work out the limit. I know that UN plus 1 is equal to UN is equal to the limit. So UN plus 1 equals UN equals L. But I've got to see if they will come to a limit. So I'll look at the number in front of UN, 0.8. 0.8 does lie between -1 and 1. And you must state this, so a limit exists. And that must be written in your page. So now that I've said a limit exists, I can work it out. So L is equal to 0.8 times L, add on 0.5. Remember that L is 1L, I'll put that 1 in. So 1 take away 0.8, is going to be 0.2L is equal to 0.5. Don't want 0.2L, so we'll divide by it. So 0.5 divided by 0.2. Don't like those numbers, so I'll multiply top and bottom by 10 to get rid of the decimals. So it's 5 divided by 2. Half of 5 is 2.5 metres. So the trees should stabilise at a height of 2.5 metres if he takes off that 20%. Okay, for this one it says his neighbour is concerned that the trees are growing at an alarming rate and wants assurances that the trees will grow no taller than 2 metres. What's the minimum percentage that the trees will need to be trimmed each year as to meet this condition? So really we want to know what this number is. Now they want the limit to be 2 metres, right? So that's the maximum. So we'll put 2 into that. So remember that would be L would be equal to A times L. That's going to tell me the percentage. So I'm working backwards. So therefore, if I know that the limit has got to be 2 metres, no bigger than that, we'll put 2 into that for L. So 2 is equal to 2 times A, add on 0.5. I want to tidy this up, so 2A plus 0.5 is equal to 2. So I'm going to take 0.5 away from both sides, leaves me with 1.5. That's 2A, so A is equal to half of 1.5 is 0.75. So that means that's the percentage that's left, and 0.75 means 75% is there. So if 75% is there, it means that he wants them to cut off 100, take away 75%, so they want to cut off 25% rather than 20%. So that's a wee question that's kind of around the other way. Learn how to do it, and if you see it again, then you know what to do. Okay, last wordy type question. It says a wildlife reserve has introduced conservation measures to build up the population of an endangered mammal. Initially, the reserve population of the mammal was 2,000. By the end of the first year, it was 2,500. By the end of the second year, it was 2,980. So it started off with 2,000 of them. Then it went to 2,500. Then it went to 2,980. It says it's believed that the population can be modelled by the recurrence relation UN plus 1 equals AUN plus B. So where A and B are constants and N is the number of years since the reserve started. Right, so what we've got is a wordy one, but it's back to that same thing. Find A and B. So that number there is U0. So we'll make that U0. We'll make that U1. And we'll make that U2. Now, the only reason I'm using U0 is it says that it started off at 2,000 and by the end of the first year, it was 2,500. So I've used that as the end of the first year. But you could have used U1, U2, U3. Makes no difference. So we've got 3 sets of numbers. We're going to substitute them into those equations. And we're going to solve our simultaneous equations. So what we've got then is we've got UN plus 1 is equal to AUN plus B. And I know that U0 is equal to 2,000. I know that U1 is equal to 2,500. And I know that U2 is equal to 2,980. Start in the middle because I need to know what I'm doing to the term that came before. So that's why I have to start the second last one. So I know that U1 is equal to A times U0, the one that came before, add on B. And then for U2, I know that U2 is equal to A times the one that came before, which is U1 plus B. So now I can substitute those numbers into those 2 equations to get my simultaneous equations. So I'm going to sub in to both of them. Right, so when I sub into them, I've got U1, and U1 we already know. So U1 is 2,500. So 2,500 is equal to A times U0. It's A times 2,000, and that's plus B. And U2 is equal to 2,980, and that's going to be A times U1. So it's A times 2,500 plus B. That's my 2 simultaneous equations. I'm going to read them and write them round the other way. I'm going to put the biggest one first because it always is same sign subtract. So that's going to be 2,500 times A plus B is equal to that. So 2,500A plus B is equal to 2,980. Bigger numbers here, but it's okay. So A times 2,000 plus B is 2,500. So 2,000 A add on B is equal to, and that is 2,500. So same sign, subtract. I'm going to take that second equation away from the first one and we'll see what we're left with. So when I do that, 2,500A take away 2,000A, that leaves me with 500A. Then I've got B, take away B, disappears, whole point of it. That's equal to 2,980, take away 2,580. So when I take those numbers away, I'm left with 480. So now I can work out what A is. So A is equal to 480 divided by 500. And it was a calculator paper, so we can work that out. So therefore I've got 480 divided by 500, and that is equal to 0.96. So that's A. So I'm now going to sub A equal to 0.96 into, and we'll stick with the lowest equation, which was 2,000A plus B is equal to 2,500. So 200 times 0.96, add on B is 2,500. Work that wee bit out. So 0.96 times 200. And when I work that out, I got 192. So 192 plus B is equal to 2,500. I want B, so I'm going to take 192 away from both sides. I'm going to take 192 away from both sides. That leaves me with 2,308. And that's what B is. So therefore, our equation for that one, A and B, is going to be UN plus 1 is equal to 0.96 UN, and we're adding on 2,308, and that's a recurrence relation.